Good morning, guys. Today is May 13th, and I decided to do something a little different for your lesson today. I wanted to actually do um, some live teaching based off of your buddy practice that you guys are having a hard time with. All right, so today we're going to continue. We're doing 10-4. It's all about multiplication with fractions. Multiply a whole number and mixed number. It says I can use strategies to represent and solve problems involving multiplying a whole number and mixed number. All right, so we were dealing with the associative property, but now we're going to deal with the distributive property. And that states that multiplying a sum by a number is the same as multiplying each number in the sum by that number and then adding the products. So we'll go over what that means. Mixed numbers, they have a part that's a whole and a part that's a fraction, and then we know that our improper fraction has our numerator that's greater than the denominator. Okay, and here was a small version of how to convert the mixed numbers and the improper fractions. If you're not sure, you don't like this version, then you can always go back to the anchor chart and the lesson that I did yesterday and I did Monday. All right, so we're going to head over to the buddy practice and we will live teach over there. Okay, so this is the buddy practice and it says find the product. It says 3 times 1 and 1/5, right? So click the icon to view the fraction strip. And see, these are all the boxes that you need to fill in the answers. And if you click more, there's a whole bunch of different icons, but we don't need that right now. So what I need to figure out is how exactly am I multiplying? So in the distributive property, it says that you can separate numbers out and then add the product. It's about partial products, right? So to give you an example, I'm going to say 12 times 8 equals n. Okay, n being my unknown number. So what it's saying is that if you break it out and you do, remember, expanded form, so 12 is actually saying 10 plus 2. So what you can do is you break it out and you do 10 times 8 first, which equals 80. And then you do 8 times 2, which equals 16. And then you add them together and you get 96. Okay, well, it's saying the same thing for fractions. So what I can do first is I can do 3 times 1, which gives me 3. And then I can do 3 times 1/5. So if you do 3 times 1/5, remember that's that 3 over 1 times 1/5. And it gives you 3/5. So my answer would be 3 and 3/5. So I'd come over here, I would type in the box, and I would type a 3. Then of course I would need my fraction. So I would do this and I would type 3/5. And I would check my answer and it would tell me, fantastic, I did a great job. All right, so let's try it again. We're going to erase. I'll leave our distributive property example up here. Okay, so now I have 2 times 1, which I'm going to do first. So 2 times 1, we all know anything times itself equals itself, so that equals 2. Then we're going to do 2 times 3/4. So 2 is really 2 over 1 times 3/4, which equals 2 times 3 is 6. 1 times 4 is 4. But now I have an improper fraction. So I have to remember I have to convert. So I'm going to bring down my house, right? Because my line means divide. How many times does 4 go into 6? It goes once. So we're going to subtract. I have 2 left over. And my 2 left over, instead of it being R2, it's going to go over my divisor. So now I have to add 2 plus 1 and 2/4. And I know that 2 plus 1 gives me 3. And then I don't have any more fractions to add, so I just add my 2/4. So let's see if Mrs. DiMeola is correct. And wunderbar, there we have it. All right, so let me erase. Leave that rest of that there for just a second. And we'll move on. Okay, so now you have this one. I don't know if your problems are the same, but let's pass it because we just did this twice. Same situation. Okay. And it looks like all of these are pretty much the same. So we're going to go ahead and let's look at the word problems because I know you guys always have questions about your word problems. So it says here that which student, Raphael or Avery, correctly found 3 times 2 1/8. So it says Avery broke a part and multiplied each part by 3. Raphael changed 2 1/8 to a fraction and multiplied. Avery broke 2 1/8 apart, multiplied each part by 3. Both methods are incorrect. Or Raphael changed 2 1/8 to a fraction and multiplied. Only Raphael's correct. Or Raphael changed 2 1/8 to a fraction and multiplied. Avery broke it apart, and each method is correct. Well, how do you figure it out? Is that you have to do both of the students' work. So if Avery broke it apart, first Avery did 3 times 2, which gave her 6. Then she did 3 times 1/8, and 3 times 1/8 is 3/8. Now, Raphael said, well, I changed 2 1/8 into a mixed fraction. I'm sorry, from a mixed fraction into an improper fraction. So I'm going to go ahead and erase this really quick. And how do we do mixed fractions to improper? First, we multiply the divisors with the whole number. I'm sorry, the denominator with the whole number, and I get 2 times 8, which is 16. 16 plus the numerator gives me 17. And I put 17 over 8. So now I'm going to take 17/8 and I'm going to multiply by my whole number 3. And remember that 3 is over 1. So obviously our denominator stays the same. And what's 17 times 3? Well, let's think about this. 3 times 7 is 21. I'm going to carry the 2. 3 times 1 is 3 plus 2 more is 51. Now I have an improper fraction. So I need to make that improper fraction back into a mixed number. So I pull it down my house, put my 51 underneath. I'm going to cross this out so I don't use it. How many times does 8 go into 51? Well, I know that 8 times 7 is 56, so that's too much. So that means 8 times 6, which is 48. Now I'm going to subtract. I have 3 left over. My 3 goes over my denominator. And I can see I have the same answer for both students. So that tells me that both methods are actually correct. It doesn't matter if you put the mixed number back into a improper fraction first or if you break it apart. All right. So here we have another word problem. Now, I don't know if your word problems will be the same on the buddy practice. I know a lot of times the buddy practices are different, but if you get the same word problem, why don't you click the bottom button that says similar problem? That way you get a different one, okay? So it says the stadium contains 7,372 outfield seats and 6,500 clubhouse seats. There are 1,348 more infield seats than clubhouse seats. How many seats are in the whole stadium? So this is an addition problem, but it's a multi-step problem. So there's 1,348 more seats infield than the clubhouse. Well, I know what my clubhouse seats are, which is here. So if there's 1,348 more, my first step is to figure out how many infield seats I actually have. Once I figure out my infield seats, then I have to add that amount plus the 6,540 plus the 7,372 and get the full amount. Okay? Last and final. Which expression can be used to solve the problem? So now this goes back to you making sure you dissect the problem. Okay, Riley has 7 cans of sauce. Each holds 5 and 5/8 ounces of sauce. How many ounces of sauce does she have altogether? Or he have altogether, because Riley could be a boy or a girl. Okay, now, what type of problems have we been doing? So we need to decide. First, we can multiply 7 times 5. Then we can multiply 7 times 5/8. So, which problem would represent that? Which one shows distributed property? Okay? So you are going to go ahead and solve these problems on your buddy practice. If you have any questions, please contact me, contact Mrs. Lyon on the math board. And that is it today. So you are logging in to Envisions, completing, and it tells you buddy practice, 10-4 buddy practice. And then I believe I wrote next to it May 13th. Okay? Have a great day.